Okay, so this is class 4. We're going to talk about graphs and graphing utilities. GeoGebra, graphs, and graphing utilities. Okay, the coordinate plane, also known as the Cartesian plane, named after its inventor René Descartes. So C-A-R-T-E-S, that's part of his name, and so we call it the Cartesian plane. Okay, so here's a picture of the coordinate plane, several points plotted. Let's quickly discuss everything we remember about the coordinate plane. What do you know about this picture? There's 4 quadrants, yep. It has an x and a y axis. There are positive and negative values for both x and for y. Good. How do you plot a point? X comma y. So you go over for the x and then up or down for the y. Anything else? What's this point at the middle called? 0, 0 is the origin. Yep. Good. We use this coordinate plane to help us visualize the relationships between 2 variables. So we often call those variables x and y. And a graph is just the set of all points x comma y that satisfy an equation. So today we're going to learn several methods for generating and analyzing the graph of an equation. So our first sort of most primitive method, and when you hear primitive, don't think bad, right? Think I can always do that, is plotting points. So if we're just going to generate several points x comma y that satisfies this equation, plot them to get an idea of what it looks like visually. So I've given you several x coordinates, right? So what I'm going to do is I'm going to take each of these x's, plug it into the expression 4 minus x squared to get the y. Okay, so if you put a -3 in for x here, what do you get? You get 4 minus -3 squared. Well, what is -3 squared? 9. Because when you do -3 times -3, you get positive 9. And then 4 minus 9 is -5. So the point on my graph is -3, -5. And so then I could plot it by going left 3, down 5. So then I just do this with all the x's that they gave me, right? So if I put in -2, I have 4 minus -2 squared. That's 4 minus 4, which is 0. So my point is -2, 0. Plot that point. Left 2, don't go up or down. All right, finish filling in this table of values and plotting the points, and then we'll see what it looks like when everybody's done. So when I plug in -1, I end up getting -1, 3 as my point. 0, 4 is done for you. If I plug in a 1, I get 1, 3. If I plug in a 2, I get 2, 0. And when I plug in a 3, I get 3, -5. Yeah. Okay, so I plot all these points. -2, 0 is done. -1, 3. 0, 4. 1, 3. 2, 0. 3, -5. Okay, so if I were to try to connect these with a nice smooth curve, I would get something like this. What's the name of a graph that looks like that? Anybody remember? Parabola, yeah. So it's a parabola. It's the graph of a quadratic equation. So probably in a previous class, you learned all kinds of techniques for how to graph this thing. Where is its vertex? Is it open up or down? So there's all kinds of techniques you can use to know what the graph of this thing looks like. But even if you don't know any of those, you can graph it by plotting points. Right? So you can always generate a graph by plotting points. All right, so now try another one. Graph the equation y equals the absolute value of x by plotting points. So when you take the absolute value of a number, it takes that number and makes it positive, right? So when you take the absolute value of -3, you get 3. The absolute value of -2 is 2. -1 is 1. The absolute value of 0 is 0. It's not negative, so you can't make it positive. That doesn't make any sense. So 0 just stays 0. Absolute value of 1 is 1, 2 is 2, and 3 is 3. So these are my points. I've got -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, and those would continue in that pattern forever. So there's my graph of the absolute value of x. All right, so some important features of a graph are the x-intercepts and the y-intercepts, places where it touches the axes. So let's go back to my 4 minus x squared, y equals 4 minus x squared. What's the y-intercept of this graph? 4. What are the x-intercepts? -2 and 2. Places where it touches the y-axis is the y-intercept. And places where it touches the x-axis are called the x-intercepts. How about in the absolute value of x? What's the y-intercept? 0. What's the x-intercept? 0 again. So the way you find the x and y-intercepts, they are the places where the graph crosses or intercepts, which is why we call them intercepts, the x-axis. Those are x-intercepts. And similarly, the y-intercepts are places where you cross or intercept the y-axis. Okay, so done. So the question is, how could we have found those special points algebraically without graphing the whole picture? How could we know ahead of time where it will cross the axes? So if you want to find a y-intercept, think of a picture of a graph, right? Any old graph, whatever it looks like. This point is the y-intercept, right? What is the x-coordinate of that point? 0. So if you want to find a y-intercept, plug in x equals 0. Make the x-coordinate 0, and it will tell you the y-coordinate of where it hits the y-axis. If you want to find an x-intercept, okay, so here's a random picture of a graph, right? I've got my x-intercepts here, places where it crosses the x-axis. What are the y-coordinates of all 3 of those points? 0. Yeah. The y-coordinate of all of these points, because to get there from the origin, I went over some amount, but nothing up or down. So the y-coordinate is 0 when you're at an x-intercept. So to find x-intercepts, plug in y equals 0. Replace the y with a 0 and solve for the x. And that will tell you where the x-intercepts are. So we can graph things using the TI-83 or 84. So if you have one of those, I'm just going to briefly show you how to use it. And then I'm also going to show GeoGebra, which is why you all have a laptop today. Okay, so if you have a TI-83 and you want to use it throughout the course, you might want to have it out to kind of follow along here. And if not, you can just kind of watch so that you can get an idea of what this thing looks like, because I might show you a screenshot of a calculator on a test or something and ask you a question about the graphs. Okay, so I want to graph the equation y equals 4 minus x squared. This is the one we already did by hand. Graphing by plotting points is kind of a tedious, repetitive activity, the kind of thing that computers and calculators are really good at. So to do this on your calculator, you press the y equals button in the upper left. If there's anything there, we just press clear, get rid of it. And I just want to enter the equation 4 minus x squared next to y1. So 4 minus the x button is up here. It says xt theta n. That's your x button. And then squared. 4 minus x squared. And then you just press the graph button. And there's the picture. So what your calculator does is it just plots a lot of points. And not just the integers, but numbers between the integers, right? Like maybe it plots every 10,000th along X. And so when we see it, the pixels are big and it looks like they're connected. So to choose a window or a viewing rectangle is important. So this may not be the best viewing rectangle to look at this graph with. The coordinate plane is infinite, right? The origin's at the center, but it goes in every direction in infinite places. So my viewing rectangle, my calculator is really small. It's not infinite. So I have to decide where in this infinite plane do I want to look. And the way you do that is you use the window button. And it asks for what's the smallest x and the biggest x you want to look at. What's the smallest y and the biggest y you want to look at. Everything else in there, I never change. The only thing I ever change is x min, x max, y min, y max. So for now, I have -10 to 10 and -10 to 20. I'm going to do -5 to 5 and -5 to 5. And it just kind of zooms in a little bit on my graph. Yes. Okay, press quit. Press enter. Go to y equals. Okay, hold on. Okay, so we've chosen a new window, and then you just press graph. You can play with adjusting the scales, but I never bother. It just is how much each tick mark, how big each tick mark is. So does that make sense? I mean, it's a really basic intro to how to use your calculator. You play around with it, and as we learn new things this semester, I'll quickly show how to use a calculator to do them as well. Okay, so some notation. If I write -10, 10, 1 in brackets like that, that means x min, x max, x scale. By -10, 10, 1 means y min, y max, y scale. So that notation is like that. And if you want to use a shortcut to get that -10 to 10, -10 to 10 window, you can press zoom 6 and it will automatically give you that window. It's called the standard window. All right. Yeah, skip that. To get a table of values from your graphing calculator, once you have the formula in the y, in y equals, you can look at the graph, but you could also look at a table of values, right? Like we plotted points. You can have your table generate a bunch of points for you by just pressing table. It's second graph. And then I can type in any x values I want, and it'll tell me the y value. Anybody have questions here? All right, so if I want to graph absolute value of x, I go y equals absolute values in the math menu. Under number, the first option is ABS parentheses. And let's see, I'll get rid of this one. Graph. Looks just like what we graphed when we plotted it by points. TI can also help you find X and Y intercepts. If you're using a TI, I will leave you to read how to do that on your own. And we're going to move on to a little GeoGebra demonstration. Okay, so we're going to do the same kinds of things we did on the TI with GeoGebra. So let me open up that program. Okay, so I want to graph the thing we plotted by points earlier, and on our graphing calculator after that, I want to graph y equals 4 minus x squared. So in the input box at the bottom, it says input, just type y equals 4 minus, and the way you type a squared is with the little like caret. It's shift 6, the number 6, you put a little caret, and then 2 for squared. So that is like the x symbol for exponent. So 4 minus x squared, press enter. Bam, we get the graph. So in the input bar, you type 4 minus x squared. Okay, so we got it graphed. Let's see. If you want to change the window, like in our graphing calculator, it's really easier in GeoGebra than in your graphing calculator because you don't have to think about where you want to look. You can just drag it. Right, so you click this little Move Graphics View button, the far right, and then you can drag this thing around. And if you want to change the scale, move the cursor above the axis, and you just click. When you get the double arrow, you can click and just drag it. Play around with that for a minute. Okay, so I'm going to skip generating a table of values in this for now. If you want to find x or y intercepts, you can just inspect visually, right? So when I look at this graph, I say, oh, look, it's got a y-intercept 4, x-intercepts at -2 and 2. In this one, it's really easy to tell because it goes right through integers. But if you weren't sure, you would type in the equation x equals 0. What line is that? What line is that going to graph? The y-axis. It's going to graph the vertical line, the y-axis. Okay, so now you can see it's a little bit bolder now because I graphed it. And I'm going to also graph y equals 0. What line is that? The x-axis. And now if I want to know where my graph, the parabola, intersects the y-axis, I type in the input bar intersect, then a square bracket, and I'd like to know where my parabola, which GeoGebra named C, right? I would like to know where that intersects the y-axis, which is the line x equals 0. So I'm going to type in C, comma A, because those are the things I want to know where they intersect. So I've got intersect written with a square bracket, and then I'm going to type C, comma A. So GeoGebra names things as you graph them, and then you can refer to those names in other commands. So it plots the point 0, 4, and that's the place where my graph intersects the y-axis. And then you could do the same thing for the x-axis. Intersect, and this time I want A, comma B, because I want to know where it intersects the x-axis. Oops, not A, B, C, comma B. Intersect C, comma B. Square bracket. Square bracket. And you can see it's plotted these 2 points, B and B2, at -2 and 2, and it told me the coordinates over here on the left.